Well, my favorite student, good old Ann. In a flat corner, so now I'm thinking a horizontal circle, car going around a corner. You know what? Car going around a corner, I think, is also on the test. That's a nice one. What I told you, the key to doing this was to draw a good free body diagram. What I typically did was a front view. I imagined the car going around the corner with the headlights coming towards me like that. And then I could do my free body diagram. I could say, what are the forces acting on it? Get the obvious one. I definitely have mg. I definitely have normal force. It's going around a circle, so there has to be a force pointing towards the center. What force is that? Well, I know it's Fc, but Fc never shows up on my free body diagram. That's the resultant of all the vector forces. This is going to be friction. So as an equation, I get friction is what's pushing me in a circle. Although usually instead of Fc, I just wrote MAC. Which version of A am I going to use? They mentioned or asked for speed, so I'll use the one with the V squared over R, with the V in it. And friction is mu times the normal, it's mu times the normal force. And then I would have said, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. So many of you might have jumped to mu mg right away. Can little cars and big trucks go on the same roads? Why? Well, that's helpful. I'm going to get the V by itself. Now, as far as I'm concerned, then, Paige, for a car going around a corner, there are 1, 2, 3, 4 variables. And I can give you any 3, find the 4th. Even ask you to find G on a mystery planet if I wanted to. That would be a fair game question as far as I'm concerned, too. Here, they want me to get the V by itself. Oh, I get my old friend, the square root of GER, although there's also a mu in there, but that's not that big a problem. Probably tells me I did it right. It's going to be the square root of, what's mu? 0.655 times 9.8 times 30. That's crazy fat. Oh, square root. 13.9? If you got that, I would give you 3 out of 3. Otherwise, I would probably do something like, I don't know, half mark for that, half mark for that, half mark if I saw that, half mark for the numbers, 1 mark for the answer, something like that. I don't know. Number 2, a 2.5 gram spider. Nice try, Duick. 0.0 is 0.025. Is that 2.5 grams? How many grams is that? That's 25 grams. It's 0.0025 kilograms. With a period of, 19 centimeters. Nice try, Duick. 0.19 meters. Okay, they want me to find the speed of the spider. I guess the speed is going to be 2 pi r over the period. Oh, that works. They gave me all that. It's going to be 2 pi r 0.19 all over the period 0.682. No squared in this equation. 2 pi r over the period. And I get 1.75 meters per second. By the way, what direction is this spider accelerating? Toward the center. What direction is FC, towards the center? What direction is this speed? Not towards the center. The fancy phrase is tangent to the radius, or if I give you a picture, at right angles to the radius, at right angles to the circle. There will definitely, on the multiple choice section, I guarantee there will be several conceptual direction questions. And I've just told you the 3 questions I can ask you: acceleration, force, or speed. You can go get it now. It's okay. You really jumped when you lost it, though. It was like it left from your fingers or something there. Students on YouTube, what? Someone dropped a pen or pencil. They're a little embarrassed, but I won't say their name because I wouldn't want to embarrass them publicly. Find the friction coefficient. You know what? I think it's going to be an almost identical free body diagram as before. The only difference is it's going to be a little spider. Okay, there's my spider. What are the forces acting on it? Still mg, normal force, and still friction is what's pushing us in a circle. It's going to be friction equals MAC. I chose to use the 4 pi squared r over t squared just in case I got A wrong somehow. And again, I said it's mu times the normal force. I don't know the normal force. Oh, but look. It's mu mg. Oh, conveniently, the mass of the spider is irrelevant. Now I'm going to get the mu by itself. I guess I would just divide by g. Mu is going to be 4 pi squared r all over g t squared. It's going to be 4 pi squared 0.19 all over 9.8 times, was it 0.652, I think? 682. Don't forget the squared on this one, Mr. Dewitt. 4 pi squared times 0.19 divided by 9.8 times 0.682 squared. Do you get 1.65? Which is a really high mu. Well, it's got sticky feet. Units for mu for a coefficient of friction. Oh, there are none. Okay. 3 out of 3 if you got that. Otherwise, I would probably go, let's see, 1, 2, 3, 4, 5 steps. Probably half mark for that, half mark for that, half mark for getting the mu by itself, half mark for the numbers, and 1 mark for the answer or something like that. I like this question, I like this question, I like this question. In this question, I gave you the period of rotation. I would also have no problem giving you or asking for the speed of rotation. Then you would use the circular motion equation with the v in it, not the one with the t in it. But this is a job for a free body diagram. So if I imagine the gravitron, here's the wall, here's a person sitting against it. What are the forces acting on them? Well, the obvious one, I definitely have gravity down. Are they sliding down the wall? Are they sliding up the wall? Normal force. No. It's not a normal force. Of course it's not, because a normal force is always at right angles to the surface. I know there is a force there. What path are they tracing out? A circle. So where is there also a force pointing? I know there's a force pointing towards the center. You know what? That's the wall pushing. That's the normal force. And usually when I do that, I go, I bet you I know what that upwards force is. It's friction. Now I start out by saying this. Normal force is what's pushing me in a circle. Normal force equals m 4 pi squared r over t squared. I guess I'm going to get the r by itself, but there's a problem. I don't know the normal force. And I cannot say, oh, but look, it's the same size as mg or the same size as friction. It's not. It's the same size as nothing. It's an unbalanced force in this equation. But I can say something else. I can pause here and I can go write a vertical force equation. For my vertical force equation, I have friction has to be the same size as gravity. Mu times the normal force has to be the same size as gravity. Now I know the normal force. In this specific situation, apparently the normal force is equal to gravity divided by the coefficient of friction. I'm going to walk that over to here. I'm going to get gravity divided by the coefficient of friction. That equals m 4 pi squared r over t squared. Mason, can little kids and grown-ups go on this ride? Why? Well, that's a bonus. So for this specific situation, Sarah, as far as I'm concerned, there are 1 R, 2 T, 3 mu, 4 G if I put you on another planet, 4 variables. I can give you any 3, find the 4th. They're all fair game. Or instead of giving you the period, I could have given you the speed. You would have a V squared over R here, and so you would have a V, an R, a G, and a mu. Still 4 variables. I can give you any 3, find the 4th. What was I asking you to find here? Minimum safe radius. Oh, we're designing the ride. So get the R by itself. I guess the G would drop down like a domino. The T squared would multiply over. The mu would stay there. And the pi squared would move there. Stuff moves diagonally. That would equal R, although I'm going to write the R equals right there. All right, now it's plug and chug. Complicated, but still plug and chug. G, 9.8. T, 3.2. Don't forget the squared. What's mu? I don't know what's mu with you. 0.45? 4 pi squared. 9.8 times 3.2 squared divided by 0.45 times 4 times pi squared. That looks right, Mr. Dewick. Do you get 5.65 meters? That seems about right for a ride like that. If I got like 500 meters, I would be saying, no, they don't build rides that big. If you got that, 7 out of 7. Otherwise, in terms of part marks, I would probably do something like this. Let's see, Mr. Dewick. I would give you 1, 2, 3, 4, 5, 6. Sure, that works. I would go 1 mark if I saw that, 1 mark if I saw that, 1 mark if I saw that, 1 mark if I saw that. That's 4. 1 mark for that. That's 5. 1 mark for the numbers. That's 6. 1 mark for the answer. That's 7. Something like that. Can you give yourself a clear score out of 15? But I don't want you to hand them in just yet.